Hello everyone, my name is Vanshi Sethi and I am a third year student of DSAI at IIT Guwahati. Today I am presenting my internship one, that is DA 377 for evaluation, that is machine learning based early warning system for risk management. This model is a real-time system or tool that is being deployed on the Streamlit cloud, which can predict the risk score for various companies. I did this project as a part of my internship at Portfolio Vibes as a data analyst for a duration of 16 weeks. This system is being tested on the Amazon's stock market data and achieved an accuracy of 80.8%. So let's start with the introduction of this project. The market of companies, we know both within and outside, is constantly fluctuating due to various factors like economic change, competition, and global events. So it is very crucial to understand this risk in the market or within these company so that they can take timely action against these kind of risk and also prevent it. So to build an effective early warning system, we need to use machine learning model to analyze the financial stock market data and also the news articles to predict the risk. So what is I can say advantage of this model is that it takes into consideration both internal data, that is the stock market data, and external data, that is the data collected in real time from the various articles present online on the web. So let's see this problem. For this model, we used historical data set. Let's say we will be using Amazon. Okay, so we will calculate the three parameters for it, which we will be using in this model. So these are volatility, value at risk, and also the Sharpe ratio. So we used multinomial logistic regression machine learning based technique for the stock market analysis in this problem. Also for the external data, means the news articles, we will be using Gemini API based sentiment analysis, and finally we will create a dashboard in the end. So this is the whole thing that we will be doing in order to solve this kind of problem in this real world. So now let me explain you the workflow or the system architecture. Firstly, we collected the data, then we cleaned the data and calculated all the three parameters, which were volatility, value at risk, and Sharpe ratio. Then we did the risk labeling, whose scores were generated using a user defined function, which we'll be seeing later on. So I will explain you that user defined function used for the generating the scores of the risk in detail later on. Then we finally use this model and API key based analysis was being done. So this is the whole thing, the main 5 steps in this whole project. Yes. So in order to understand this model, we need to know about the three parameters or strategies that we'll be using. We know the first thing is volatility. So what actually is volatility? It is the measure how much of a stock price fluctuates over time. Means high volatility will mean high price swing will be there and high risk will be there. So lower volatility signals stability, on the opposite. Okay, so it just explain you the fluctuations. More is the fluctuation, more is volatility, more is the risk. Then we have VAR, which stands for value at risk. So what actually is value at risk? It is the maximum loss that a stock can experience over a defined time period within a confidence level. Let's say we chose 95%. It means that there is only a 5% chance that the loss will be more than the value predicted by this VAR. Then the third thing that we will be using or parameter is Sharpe ratio. So what does Sharpe ratio do? It measures the risk adjusted returns by comparing the excess returns to volatility. Means higher Sharpe ratio means better returns for the risk taken. So you know that if you are taking some kind of risk, then you will want more return to be there. At the same level of risk, you will prefer that kind of stock which is giving you more return. So that is what is being predicted using Sharpe ratio. Now let me explain you the coding part. So mainly we are having three files and I will be explaining you all of them one by one. So this first one is the early warning system data for stocks. So it is how we will be getting the data for the stock market for various companies. So for this we are using the Y Finance library, that is also known as Yahoo Finance. So what we have to do is we have to put the ticker over here. That is a kind of acronym used for various companies, and for a particular company, if you don't know the name, you can search it on Google and put it over here. Then you will be writing the start and end date for which you will be collecting the data, like it's written 1st January 2010 to 1st January 2024. 14 years of data will be there in our CSV. And finally, using the pandas library, we have written this line like historical data to CSV, or we are downloading the CSV file data, and the data is being extracted using this Y Finance library. Now second one, this is our whole model, how it is actually working. So for this, firstly, we imported the essential libraries like pandas and numpy for data processing. Also, Plotly is used for making the visuals or graphs. Then sklearn is used for machine learning part, and Streamlit for UIs. And request is used for web requests. So after that, here it is title, markdown, all these things. So this is the first thing in Streamlit. So it is the title and description of our tool that will be shown, or we can say displayed on the dashboard. After that, we have this user defined function. So it is a two-step API process. It will search for the news articles and then perform the sentiment analysis as well. Then we have this JSON part. So what actually is this part is for the risk analysis. You will be giving the scores. Okay, it will give you the score 0 to 10, a risk score, and also the sentiment, that is positive, negative, or neutral. Means JSON structure will be given in the output. So this is being performed using this whole part we have written. You can read it in detail. After that, we have this sidebar thing. So this is the arrangement that will be visible on the dashboard. So we have arranged the sidebar controls, clean UI to upload the file, toggle for news, and API key as we can say input will be providing for the Gemini API analysis. Then what we did is we uploaded the file. We will clean the file, and also we will convert the dates to standard format. We will remove the missing values. So this way our data will get ready for any kind of analysis we'll be doing later on. So after that, we arrange these matrices, which were the volatility, VAR, Sharpe ratio. We arrange this. After that, this is the important part that I was explaining earlier, user defined function. So what we are doing here is, you can see here in this, we are doing risk classification. 4 plus is high risk, 2 to 3 is medium, and less than 2 is considered to be low risk. Okay. So we compare the current volatility to zero point 0.5 quantile, or we can say percentile, means 75th percentile. So if VAR is less than 2%, it will mean the potential loss exceeding this value. Then Sharpe with 0 means less than 0. If Sharpe value or ratio is negative, it means that the return less than risk free rate. So then we are adding 1, as stable stocks with poor performance are also considered to be risky. So these are some of the numbers which are chosen by us, but this whole thing is considered to be valid for this kind of prediction, because of these explanations I just gave you. That plus 4 means accuracy. We are saying volatility. Yes, for volatility it's zero point 0.5 quantile. So we are saying that even if there is some kind of fluctuation, we are not saying a particular stock is really very good, and we are not saying a particular stock is just totally unstable. So 75th percentile is a very safe number that will help us to make our analysis much easier. That is why we chose this particular number. This is also being written in some of the research papers as well, which I will be providing as reference in my report also. So this is the whole thing that helped us to make this prediction much easier and accurate as well. So after that, the next thing we did is we split the data into training and testing part. And we also used L2 regularization to prevent any kind of overfitting. Yes. And after that, we also made this confusion matrix in the form of a heat map. So this is really very important. It is a visual that will help us to understand the model's performance. And finally, we also added the predictions, the final predictions that our model will be making, and also the visuals, and also that we can download a CSV file simply that will provide us the risk probabilities for the various values or various, I would say, dates. Yes, there will be a opening and closing date in the stock market data, and corresponding to that particular date we'll be getting a risk score as well that will make our prediction much easier. Or even the people who want to invest in these companies can also take a look at this kind of data. It will help them in making better predictions whether to invest or not, or when to invest. And after that, we also have this real-time news integration, which was from we used for sentiment analysis using Gemini API key. So this was the whole project, and now I'll be showing you its dashboard. So let's open its dashboard. Oh, one thing also, I wanted to show you that last file request.csv. We'll wait for a minute for this to open. After that, we'll move back to that part as well. Okay, so till then, when it's opening, let's look at this. You can see here this request.txt file is a simple text file with the requirement, means we are providing all the libraries and what are their versions being used in our file. This is a very important part while using it for deployment, because in the final step, after we made this whole Streamlit dashboard for its visualization or better UI, we have finally deployed this whole project. So for that deployment part, this request file to be present in our repository is very much important. Okay. Now let me explain you this dashboard. Firstly, we have to select that CSV file which is containing the stock market data for that company, like this Amazon historical data, which we downloaded from Y Finance earlier. I had shown you. So we will open it. It will clean the data as we had written in our code. So you can see here now the missing values are 0, and it contains the data from this to this time period. And after that, we have this risk matrices. You can see here volatility of 32.6%. It indicates that the fluctuations are there, but its low value means somewhat lesser risk. Then we see the Sharpe ratio is 0.04, which is quite low. So it indicates that the risks are barely above the risk-free rate. Then this VAR value with 95% confidence is having the value of 46%. So this negative of 46% indicate that the loss, there is a chance, means only 5% chance that the risk will exceed 46%. Okay, then we can see the distribution. Low labels are almost 0, negligible. Then medium we have 2625, and the high value risk labels are 892. When we apply logistic regression on these, we got to know that the distribution becomes this and this for the training and testing part. And you can see here that accuracy of 89.5% is there for our model, then precision of 90.1%, recall 89.5, means that the model is correctly identifying 89.5% of the overall positives that are present. Then similarly, the F1 score, which shows us the balance, or we can say the harmonic mean in that recall thing, and also with precision. Then we have this confusion matrix, which shows us this kind of correlation between these values of risk, high and low label risk. Along with that, we also have these prediction values. You can see here we have the date, we have the closing values, and the corresponding risk labels that were being generated. Okay, then I'll explain you these graphs. You can see here in the volatility part, there's a lot of fluctuation in the earlier part of this graph. Then somewhat it is stable over here. So this lot of fluctuation means high volatility, high risk, and this is more stable means lower risk. Here are also some fluctuations, but as compared to this part, it is much less. So I would say this is the best stable part, stablest. This one is much stable, but this one is having the highest risk, and most of the fluctuations are over here till I think 2011, or we can say October 2010 or November. Then similarly for this VAR means value at risk, you can easily see that there are negative means maximum loss. Large negative spikes show maximum loss, or we can say the market stress, and it somewhat decreased over time. So also in the earlier part it was quite high. And also in the Sharpe ratio graph, you can see here that earlier timeline has negative values, means poor risk adjusted returns are there. Over time they got almost close to zero, so it somewhat became more balanced. So I can say in the earlier timeline of this graphs, there was much higher risk rate or market stress. After that it got somewhat stabilized. For this, you can download the CSV files of the risk label generated. I will show you that as well. Yeah, you can see here the risk labels, medium risk. Also, I would get, yeah, high risk. So what is actually here? We have the date in standard format, we have the closing values along with the volatility means for yearly thing, and also the Sharpe ratio, VAR, and corresponding label. So these are the three parameters that we use in the whole model that helped us to realize the risk potentials present in the market over the time period of 14 years almost. So this is the file we had generated. Now let's get back to our dashboard. Also, we have to do that external market data analysis, that is this using this Gemini API key. So how we will be doing it? We have to put the company's name. Company's name is Amazon. Yes. And its ticketer, as you remember, AMZN. Yes. Now we need the Gemini API key. Okay. So we'll have to get it from, let's say, Google Studio. Get API key. Yeah, I will copy the API key and will paste it in this. I'll press enter. You can see here currently its value is indicating at 6.5 upon 10. Negative sentiments are there in the market. Means regarding the news articles, you can see Amazon reported strong financial results indicating 14% sale urge and also 24% growth in the AWS, signaling the solid foundation of health. Despite this, the stock dipped over 11% as the investors were rattled. So we can see that according to the news articles that are being present in the web, it is considered that Amazon is at risk currently, which is somewhat true. But we cannot totally rely on this part, as the news are somewhat kind of rumors also. So we should also take into consideration these graphs as well. But we cannot totally rely on these graphs also, because this data is real time. For each and every moment, this value can change. But this will remain same for, I would say, a week or two. This is because this data is historical. So that is why this stock market data is really, I would say, confusing to people. So what we can actually do is we need to, as an investor or as a part of this company, we need to make sure that we are taking into consideration both of these things. the historical data, that is the internal data or stock market data, and also the external news sentiments regarding that particular company. So these are the experimental results for Amazon's data. We had done 80 by 20 split for training and testing. And over here it is shown the accuracy, precision, recall and F1 score which we had seen earlier. And also these visualization which were available in our dashboard. We had got to know that till October 2010, the risk was quite high. After that, the market for Amazon's company stabilized somewhat. So we had successfully built this project that included the elimination of look ahead bias because of the expanding window. Also, we provided the scores, or we can say risk score, not only based on only one parameter but three parameters taken into consideration, that were volatility, value at risk and Sharpe ratio. We had taken into consideration both data, internal as well as external, that is the stock market data as well as the news articles present in the um, to the users, I would say, or the people who are investing in this stock markets. So this, yeah, so there is actually one more thing that I wanted to share. So why particularly I chose Amazon for this project, I wanted to discuss that part. I chose Amazon because it has an online market, e-commerce. It is also selling third party products, means it is getting some goods from some place and also delivering it to our homes. And also it has some physical stores like in Seattle, which is totally AI based. And also some devices like Kindle, Alexa, Fire TV, these are being provided by Amazon. Many other also. Amazon Prime is also there, used by for entertainment by people to watch the TV shows, movies, web series. And also we have AWS, that is the cloud system used not only by Amazon, various startups and various companies are using it. Okay. And also in the healthcare part also there is some pharmacy with Amazon. And in gaming, Twitch, which is available, also used Amazon services. So when we are talking about the risk of Amazon, it is not just indicating about this particular company, it is covering a global market. So this helps us to know about the economy also. Like Oracle, I could have also taken Oracle as well because it is also providing so many things, but I realized Amazon is much more versatile as compared to Oracle. So I chose Amazon, that is showing us not only its own risk but risk of much bigger portion of the market. So we can see this overall thing from the eagle view. So this was one part that I wanted to discuss markets. So this takes us to the end of this detailed project. And for the submission, I am attaching this PPT, this video, and also the report dashboard that is being deployed. And also the link for the repository is available in the final report that I will be submitting. Thank you so much.